My name is Douglas Zook. I'm a biologist and I teach science education and global ecology at Boston University. And I've been working in symbiosis for many, many years, both teaching-wise and research-wise. Symbiosis is really a prevalent form of existence for living organisms all over the planet. It's really partnerships among different organisms, living beings that really are so dependent upon each other that they become almost one entity. In fact, we now kind of say that the individual is really made up of different organisms, any individual, including ourselves. And so symbiosis is not just this relationship, but it's a long-term relationship, something that lasts. I also define it as a relationship that ends up producing new structures, new bodies. You have a coral reef, for example. A coral animal merges with a particular type of algae, like a plant, and the two come together and they build a reef, this massive area that is so important to the earth for biodiversity. That is a symbiosis. It has an outcome, a reef. It has two different partners that are very, again, different from each other, and they merge and they last for a long time. This is symbiosis. It's not really something rare. We see it as very common. Even our own cells in our body have a symbiosis. We would call that more of a symbiogenesis. That is, each one of the cells of our body have mitochondria. That is part of our body that's so important in energy transfer and energy usage. Those mitochondria were once free-living bacteria and entered cells that then became animals and that then became us. So this is a merger of a foreign organism, a bacteria, with other cells. And this is part of a symbiogenic process. That is, it's an evolutionary process where the organisms have developed so much and so intimately that they become what we call an organelle system, that they're intertwined. You really can't take the mitochondria out now and have it grow on its own. It's totally involved in our body system. This is a symbiogenic process. This is a process that is really accumulating the two sides, the two different organisms, and building it over time into this evolutionary, very tight expression. Symbiogenesis is something that fits very well with natural selection. The only reason why Charles Darwin and Alfred Russel Wallace really didn't focus on it is because there wasn't much known about genetics and known much about transfer of genes from one organism to another. But now we know that, in fact, it's natural selection, which is really what's left over. It's the organisms that fit best in that environment, and all the others die off or are not so prominent any longer. Natural selection goes forward. Symbiosis fits right into it, but symbiosis is a major form of novelty, of variation. In order for natural selection to work, Darwinian natural selection, it has to have varieties to, quote, choose from. Nature is choosing, one could say, and again it's an anthropogenic term, but choosing or selecting those organisms that best fit in that environment. But if there aren't many varieties, if there aren't new examples to choose from, it's a problem. You don't have evolution moving forward or moving in any direction. So symbiosis provides that variation, that novelty, even more than mutation. It's providing novelty in the sense that here's an organism with a whole set of genes that is expressing itself, and this other organism can capture and bring it in one gulp, in one swallow, so to speak. We see that throughout the world of organisms. Whereas mutation is really a series of changes in the genes that most of the time are deleterious. That is, it kills the organism or injures it. And it's only very slowly that you accumulate positive changes. But in symbiosis, you have a rapid swallowing up of an organism such that you all have, the organism has a whole group of new genes on which natural selection can act. Lots of variety, natural selection can move forward. So the two really fit together and help to explain why some organisms in the long history of evolution do not have transitions. You don't see all these stages of development, which you normally would think would be there. Stage one, it's like this, then it goes here, then it goes there. In symbiotic systems, you have a more sudden expression. Just suddenly in the evolutionary record, you have this kind of expression. And that's because the whole organism has been taken in. 500, 1,000 genes are taken in all together, not one at a time. And so symbiosis fits in well with this evolutionary construct. And if Darwin were around today, he would say, wow, this is a good chapter and an important one in the origin of species. Well, the biggest thing that symbiosis does is it takes us away from the view that an individual, that natural selection and evolution operates on an individual basis, that we're really holobions. Holobions meaning that there are no individuals, that an organism only works because it has other organisms that are quite different from it involved in its system. We really can't function and do much of anything without our bacteria. We can't go through our life cycle. We can't really function very well. Most organisms require another organism to be a part of it. It can't even do the fundamental things to survive. So therefore, we would say that our concept of individual now is really is more like an ecosystem. That individuals are really groups of organisms and therefore are functioning as an ecosystem. The International Symbiosis Society is a group that I was president of for about 10 years. It's really a group of accomplished researchers and educators that are really interested in exposing how important symbiosis is both to evolution, to our daily life as human beings on the planet, how symbiosis, this partnership with different organisms, really impacts ecology and the world around us. So the society really is all about getting people to be aware of this important system on Earth. And the society has grown quite a bit. There are people from over 35 countries involved, and the journal is published through the society. I'm a little bit more involved these days in the university and in my global ecology work, but I still stay in touch with that group.